Dr. Sophia Liu. I work at the U.S. Geological Survey as a Mendenhall postdoc fellow. Now, nearly 40% of our U.S. population lives on the coast, and there are different kinds of coastal changes that are likely to occur. Waves and storm surge may erode dunes, sand might be pushed onto roads, inundation may occur in narrow parts of barrier islands. Now, USGS scientists have been developing geospatial prediction models of how likely these coastal changes are to occur in the Atlantic and Gulf coasts. Now, these models are based on NOAA's data, storm surge data, as well as beach and dune elevations from LiDAR data. Oblique area photos are also taken to validate these predictions. So USGS has taken about over 140,000 aerial photographs before and after 24 storms since 1995. But this very expensive data is actually not used much at all. We put them on interactive maps, create a handful of photos, but really we thought crowdsourcing can help make this data more useful. We applied this crisis crowdsourcing framework, which I developed to help guide the design of this system. So really, the issue is USGS just cannot analyze all the photos that we collect after every storm. Computers cannot yet automatically identify the kinds of geomorphic changes we are looking for in these photos, and USGS prediction models still need to be validated in ground truth. So we're not just going to ask random people, we really want to target people with coastal expertise. We will ask other crowds, but ultimately we really want to target coastal stakeholders. So the IPost project is really not just about designing a technological interface, it's about bringing innovation to the social, organizational, and political interfaces. And federal policies need to better reflect what is happening in practice with these emerging technologies. We've been developing IPost since January 2013. Multiple prototypes have been collaboratively developed and internally tested with USGS scientists, and each prototype has evolved in its design, but also the social, organizational, and political interfaces were also designed as well. So here's a current view of IPost. We basically ask people to look for a pre-storm photo that best matches the post-storm photo, because the computer just looks for the nearest photo. We also ask users to look for specific types of coastal infrastructure and indicate what kinds of damage they see. We integrated this magnifying tool that allows people to zoom in and out of the high-resolution photo to identify the kinds of features like sand fences in this photo. So users are asked to select predefined keywords like dune scarp or inundation, but if the user does not know what that word means, then a pop-up box appears to provide additional information to educate users about coastal hazards. So once we collect this crowdsourced data from IPost, we can use Bayesian networks to create correlations between these different observations. The USGS coastal prediction model really only focuses on the beach and dune geomorphology, geologic changes. But IPost also extracts information about infrastructure damage and disaster recovery efforts, which are human systems that are not yet incorporated in these USGS prediction models. So the geologists now see the value in using IPost and the crowdsourced data we can generate because it can inform the coastal vulnerability assessments. We're starting to use Bayesian networks to create these predictions from the crowdsourced data. So for example, if we know for sure there's a dune scarp, then we can predict that there's 75% likelihood of dune erosion and 30% likelihood of seeing damaged sand fences. So we made these predictions just based on an internal study conducted with USGS scientists. We are beginning to explore ways of mapping these predictions to see how we can crowdsource this data and ground truth it with the prediction models. Now the USGS National Earthquake Information Center, which I had previously worked at, develops a series of earthquake products. Crowdsourced data from the Did You Feel It maps are then incorporated into the shake map and ultimately gets integrated into PAGER when major earthquakes occur. So the USGS Coastal Marine Geology Program is beginning to offer similar geospatial hazard products to develop accurate vulnerability assessments. We hope to create a similar system using crowdsourced data from IPost to then validate the USGS prediction models and produce real-time coastal vulnerability assessments. So the mission of IPost is really to design a crowd tagging app that uses citizen science techniques, use that crowdsourced data to validate prediction models, and we can now use IPost to be used for any future storms that occur. So crowdsourcing apps for analyzing imagery is really on the rise. Digital Globe's TomNod app uses satellite imagery, our IPost app uses aerial photos, and even FEMA's Disaster Reporter app uses on-the-ground photos. Such crowdsourced data can help ground truth and these prediction models and improve situational awareness during emergencies. So we just launched IPost this month at ipost.us. I hope you all are interested in becoming an IPost volunteer, and please spread the word to any coastal stakeholders you may know. Thank you. Any questions? Okay.